Good?
Okay, amazing. It's time to get started. Thank you all for joining us today. I'm Alicia Frame, the Principal Product Manager for Fine Tuning. If you've fine-tuned before, you've probably gotten an email from me. Super excited to be here today. I'm joined by Omkar Moore, who's our engineering lead,
Hello.
and Shri from Oracle, who will be talking about a real-world use case. But today we're going to be giving you an overview of fine-tuning and distillation with Azure AI Foundry. We're going to be talking about end-to-end demos, code first and UI based. We're going to be dropping a bunch of new features, and we're going to be talking about actual results from fine-tuned models. So it's going to be pretty exciting. I like to start with an agenda so you know when to wake up and pay attention and when you can zone out. We're going to start off with just a level set. What is fine-tuning? Why are people doing it? How does it work? 5 minutes. I'm going to hand it off to Omkar to get into the real stuff. We're going to do an end-to-end demo of distillation, evaluation, fine-tuning. And then from there, I want you to pay attention and see what the new product announcements are. Then we're going to check what you caught, and we're going to talk about what's new at Build, what's new with fine-tuning. We're going to go to another demo, another product announcement. Reinforcement fine-tuning is available. It's hard, it's confusing. Probably a lot of you are like, I don't even know what she's talking about. So Omkar is going to show you how that works. Then we're going to talk about some customer case studies, and we're going to have a customer with us up on stage. Shri from Oracle is going to tell us about their AI-first EHR, which uses fine-tuned models. And there you are hiding. Finally, we're going to talk about why Azure, and hopefully, aspirational, we're going to have some time for questions. So thank you all for joining us. So I'd like to start with just fine-tuning is finally becoming a critical skill. I have worked on fine-tuning for the last 3 years. I think Omkar has worked on it for longer. When I joined this team at Microsoft, everyone was saying, I don't know about fine-tuning. Why don't I build a foundation model? Last year it was, no foundation model. All I need is RAG. This year is the year of fine-tuning. So we did a study. 48% of developers said they're looking at fine-tuning. 29% off-the-shelf models, and only 10% are still on the build a new foundation model train. What I think is happening here is base models have been commoditized. OpenAI is great, Llama is great, Grok is great. Off-the-shelf models have pretty similar capabilities. Building a model from scratch, a foundation model, is going to be really hard, really expensive, and really slow. You get better results from an off-the-shelf model, but you don't have any competitive differentiation. You can use retrieval, but you're not really customizing it to your use case and your needs. So that's where the rise of fine-tuning comes in. You get this cheat code where you get frontier class model, plus your expertise, your know-how, your business domain. So it's really like best of all worlds. So in order to understand how fine-tuning works and why I'm saying it's kind of a cheat code, I always like to start from how do you build a foundation model? You start with pre-training, which is unsupervised. This is where you have your massive amounts of unlabeled data. I've scraped the internet, Library of Congress. I want to be able to predict, given a token, what's the next token? Step one. This makes a model that is not very good. If you've ever used a model that's only been pre-trained, I'm sorry. Next step is you have post-training. This is where you teach the model how to behave. You start with instruction tuning, where you have instruction response data, prompt response. You teach the model how to interact with you. You follow that with alignment training, where you teach the model what you want to see. And so this could be aligning the model so it doesn't say offensive things. It could be aligning it so it's agreeable. This is all about teaching it not just how to interact with you, but the best way to interact. These 3 steps equal your generic off-the-shelf LLM. Fine-tuning, you take that generic LLM, and you do those same steps from post-training. You can use instruction tuning, also known as supervised fine-tuning. So you take your best-in-class frontier model. You don't have to start from scratch. You get to cheat. You skip ahead. Then you have your data of what you want this model to know, how you want it to act, how you want it to behave, and you use supervised fine-tuning. You can also use alignment. We offer DPO, which lets you say, given these 2 responses, I prefer response A over response B. And it lets you align the behavior. And so these 2 steps let you create your new fine-tuned LLM. So you have all the smarts, all the capabilities of the frontier class model, plus your data, your use case. So you get all of the power plus whatever is unique to your company, which is a pretty powerful example. So why are people fine-tuning? I have talked to hundreds of customers. We have seen thousands of people creating fine-tuned models. And there's really 4 big use cases for fine-tuning. I think the first one, and what comes to mind for most people, is enhancing performance and accuracy. This is the people who come and they say, I work in healthcare. I need the model to understand patient data. I work in operations. I need the model to understand supply chains. I'm an accountant. I want it to know math. This is domain-specific adaptation, task optimization, what I think most people think of as fine-tuning. However, the most popular use cases are actually usually cost efficiency, cost reduction. So this is what Omkar is going to be demoing. This is distillation. I have a large model. It's super smart. It's also kind of expensive. I want to fine-tune a small model to replace that large model, but be just as good at my task. And fine-tuning lets you do that. It lets you train that small model to perform well at a specific task. So you have good performance and a small, cheap model, which is pretty good. This also can translate to lower latency, smaller, faster models, also reducing your prompt length, reducing the need for few-shot examples, so you get faster. Final example is really risk mitigation. And as we've seen in the last 6 months or so with the rise of agents, now we have LLMs that are calling APIs. They're making decisions on your behalf. They're taking actions. You do not want those LLMs to call the wrong API at the wrong time. You don't want them to do the wrong thing with the results. So a really growing area of fine-tuning is going to be fine-tuning for tool use. I want the model to call the right tool at the right time and use that tool in the right way. In the sneak peek, we're going to see a little bit of fine-tuning for agentic use cases from Shri later on. So giving you the high level, now you're all fine-tuning experts, check that off. Now we want to talk about how do you actually fine-tune. This is the PM slide. Omkar is going to show you how it really works. We start with our vision and scope. Do not come and say, I would like to fine-tune because I heard it was cool. You need to have a baseline of, I want to make this model better at this task. I want to use a cheaper model. I want a faster model. Model scores poorly. So start with vision and scope. And that's going to guide your choice of a base model. Do you want a small model for distillation? Do you want a reasoning model? And it's going to guide your choice of technique. Supervised fine-tuning teaches the model to copy. DPO teaches the model to align with your preferences. Or reinforcement fine-tuning teaches it to reason. Once you've chosen those, you collect your data set to teach the model the behavior you want. You train your model. This is honestly the easiest part, drag and drop in the UI. Then you evaluate it. It's really important to check, did I fine-tune to make my model better, or did I accidentally make it worse? So you evaluate it, you show that you've made it better, or you've identified, oh no, that was not what I wanted, and you collect some more data, you train again. Eventually, hopefully, you get to a point where you're ready to move that model into production. You want to deploy it, you want to monitor it, and eventually you're going to fine-tune it again. A new, better model is going to come out, you're going to have data drift, but this is an iterative process. So with that, I've given you all just enough to understand. Ooh, we went ahead. And I'm going to hand it off to Omkar to talk through how this actually works.
Thank you, Alicia. So today, I'm going to show you a demo that brings our evaluation and fine-tuning workflows to life. Alicia gave a great overview of the entire process. Let's see how that falls into action here. So I'm going to use Jupyter Notebook in VS Code to show a code-first experience. And at the same time, I will show the Azure OpenAI Foundry experience to show how you can do this through the UI as well. So here's what we're going to do. We're going to take a data set. We're going to evaluate it through all the base models and figure out which is the best base model that we can use for distillation, generate high-quality responses from that, and train and fine-tune a smaller model that kind of comes close to the base model with much lower latencies and better cost proposal. Let's get started. So let's talk about the data set first. So I'm choosing the SHP data set. This is a Stanford Human Preferences data set. This has a prompt, which is a question from Reddit. It has 2 human-written responses, which are essentially the top 2 answers, and then a preference label, which tells you which of these answers is more preferred by the customer. This is determined by the number of upvotes that the question has. Let's load this up in the notebook and have a look at a couple of examples. Okay. So here's a good one. So the user is asking about what's the effect of time on a food that is left outside at room temperature. So
Good question.
both the answers are factually correct, but response A goes more in detail in terms of it's not just the room temperature that matters, but also the temperature of the food itself that matters. And that's why it's more helpful. Now, these kind of nuances LLMs can often miss, and that's why SHP dataset is so great to evaluate how are the responses with respect to the human preferences and not just accuracy. With that, let's talk about our evaluation setup. We're going to use the Azure OpenAI evaluation API. It comes with a generic autograder that kind of gives you a quality score for your responses between 1 and 7. But we're not going to just use it at its face value. What we're going to do is we're going to run this autograder on top of our dataset itself and see whether it in fact scores higher for the preferred responses and lower for the rejected responses. This establishes that the autograder has coherence with the human preferences. So let's do that first.
And so what you're showing now is you're grading those base models before you fine tune it all.
No, even before that, I want to establish that the autograder itself can score the models correctly. So what we're going to do is we're going to have 2 runs, one with the preferred responses and the rejected responses, and then see how the grader scores for the ones that humans already have given. So as you can see over here, the preferred responses from the dataset scored higher with the autograders than the rejected responses. That means that there is coherence between the autograder and the human preferences. With that in place, our next step is to evaluate our base models. I've shown this in the UI, in the notebook right now, so let me switch over to the UI and show how you can kick off an evaluation run for all the base models. I'm going to use the 5 base models stated over here, the biggest and the greatest O3 reasoning models, and also the 4041 series of smaller models. So let me switch over. So here's the Foundry UI. You can click on the new evaluation, and you can use an evaluation file. Now, I have already uploaded this, so I can just use that.
And so what is your evaluation file?
So evaluation file has the question from the Reddit, from the SHP dataset, along with the preferred responses that came from the humans. Now, I'm going to ignore the responses that came from the humans. I'm just going to use the prompts and then actually generate the new responses from our base models. So let's select the generate new responses over here. And then the system prompt looks OK to me. Let me make sure that I pass along the prompt from the file.
And we're doing this live.
Yeah, we're doing this live. So then we can use, say, the 4.1 model to generate our responses. You can also choose what hyperparameters you want for the generation itself, and then click on Next. In the next step, you add what is the testing criteria that you want to use. Now, Azure OpenAI comes with a fair amount of inbuilt graders. We will use the model scorer grader, which is a model-based grader that gives you a quality score. And we'll use a more capable model like an O3 model to power the grader itself. As you can see, you have access to the entire system prompt, so you really know what the grader is actually doing. And then finally choose the actual prompt that you had from your data set. And it gives a score between 0 and 7. I give a passing grade as 5, and then go ahead.
And so why use the model-based grader instead of just a string check grader?
A string check grader is just going to check for similarity of exact questions and all. The model-based grader will check for factuality, it will check for tone, and you can, in fact, change anything that you want over that using a custom grader. So it gives you a lot of flexibility. Now that we have done that, you can add more criteria as if you want, or you can add responses from more models, like say, I want to do it with 4.1 mini as well, and then go ahead and submit the evaluation run. And while this runs, we can open up one that I already ran with all the base models and see how that looks like. So
it's always good to have a cooking show demo ready.
All right. OK, I think I opened up the one which has the fine-tuned models. So let's just
You didn't see. We're not going to give away the punchline.
All right. OK. As you can see, the bigger models score better with O3, 4.1 models, and it degrades as in how the models become slower. And it makes sense because the bigger models are more capable. In this demo, what we intend to do is to take the responses from the bigger model, like an O3 model, and fine-tune some of the smaller models to improve their scores. And that's the process of distillation. So to quickly go over back to the notebook, you can pull up all of this using the SDK as well, and we'll share this notebook for you to try it out later and can get more access, more detail into it. So real quickly, here's the distillation workflow. So you'll have an O3 model. We chose that because that performed the best on our data set. Then we create the high-quality completions and create a distillation data set and use that to fine-tune the smaller model. Let me just quickly show you how this can be done. So we're going to take the training data set of 1,000 records and call O3 for getting the completions. And now you can actually go ahead and store the file and then go ahead and pre-process it and make it ready. Or you can simply use stored completions, which allow you to simply turn it on, and all the completions will be stored in the Azure OpenAI resource itself. And you can now go back to the UI and in the stored completions tab and see all of these requests that are there. You can click on any one of them to see the entire request, including the metadata and token information, and so on. Once that's done, all you have to do is click on the distill button, and you can choose the model that you want to distill to, and then go ahead. So let's go ahead and choose for 4.1 mini. And this is a very interesting slide because you can see a few.
This is not a slide.
It's not a slide. You can see a few announcements that we are making this week. So the first up, you see something called as training type. So you have a standard and a global training type now. Global is what I'll be using because this is more cheaper. It's available in all regions, and Alicia is going to talk a lot more about that.
All my announcements.
Okay, I'm not going to say more. And then notice that you didn't have to do any pre-processing of the training data. The stored completions were automatically converted into a training data set and were there for you. Next up, you can change your hyperparameters. These are usual hyperparameters that we support. The learning rate, batch size, I'll keep that as auto, and click on the submit button. But before that, we can also click on this button, which says that, hey, I want to automatically deploy the model once the training is complete. I don't want to come back and do that here. In addition, I can now select a global tier, a developer tier, which again is a more affordable way of deploying.
I'll tell you more about that later.
Tell you more about it. All right. So let's go ahead and submit this run. While this is queued up, let's go ahead and open an existing run that is already completed. And here you can see the usual stuff. You can see we have 3 checkpoints that are available for you after training is complete that you can go ahead and these are versioned. You can continue fine-tuning from there or deploy it. You also you can look at the metrics for the loss curves and token accuracy. You can look at the logs for the detailed information of how the training went off. And finally, when you are done, you can click on the.
This one is already deployed.
Yeah, and then you can deploy the fine-tuned model, and then click on the evaluations. Now, in the interest of time, I have already fine-tuned all the base models and have created an evaluation run for us to see. So we will go ahead and just open that up. All right, that's the one. And yeah, as you see, the fine-tuned models for both 4.0 and 4.1 has substantially increased in their performance. If you look at it, 4.0 went from 35% all the way to 90%, and 4.1 also sees a decent amount of improvements, and so does the mini models. So this is amazing because what we have done is we just took the O3 model's responses. We didn't have to get new data or new labeled information, and then use that to distill and infuse the knowledge into a smaller model, which is more cost-effective. Now, to quickly wrap up, you can, let's go back to the notebook real quick, and you can just see the information about not just the model graders, so not just about the models, but also the frequency distribution of each of the evaluations and all the details over there. And to just wrap it up, like I said, we were able to improve the performance of 4.1, 4.1 mini, 4.0 with just taking responses from the 4.03 model. And we also littered a few announcements for Alicia to talk more about.
You didn't steal all my announcements.
No, I didn't. Right,
let's toggle the screen.
Yeah, we'll do.
Amazing. So I think Omkar's demo answered some of the top questions I get asked. One is, can you give me an actual example of how much fine-tuning improved a model? Can you tell me where to get my data from? And am I allowed to use another model to generate training data? Yes, and stored completions. And how does this actually work? If we go back to that slide I had before where I said, you start with your objective, get data, train, evaluate, deploy, we showed all of these steps being done in Foundry. So we had 4.1 mini. We were generating our data using stored completions from O3. We were training with the Foundry UI and the Python SDK. Hopefully you all check this out. You can run it yourselves later. we were evaluating with AOAI evals, which you can do in the UI again or via the SDK. And we were deploying with DevTier. So all of this was made super easy with Foundry. How many of you have actually fine-tuned a model before? How many of you fine-tuned a model a year ago? Oh, I'm so sorry. We have made the experience much better. So what we're focusing on right now is making that end-to-end journey seamless and painless. Fine-tuning should not be a painful process. It should be easy to make your life and your company's models better. And so if you followed Omkar's demo, starting with new models, new methods, 4.1, 4.1 Mini, 4.1 Nano, O4 Mini, and also we didn't really talk about it here, but Llama 4 Scout is now available. So new models to get better results, you can now fine-tune from anywhere. One problem people have had, including myself if you stopped by our expert booth, is you have to know which regions happen to host fine-tuning and which models are available in which regions, which is a pain. Not easy to find out. We now offer global training. So any region you go to, you can launch a global training job. No more guessing where fine-tuning is. Alongside that, we have developer tier. This is probably the most exciting announcement we have today. For those of you who have fine-tuned, have you ever complained, why is this so expensive? Yes, I get those complaints. Omkar gets those complaints. Developer tier is intended to unblock this. This is a new tier for hosting your fine-tuned models with no hosting fee. All you pay, Omkar is excited.
Yeah, I'm super excited.
He's complained to me about this for years.
Yeah.
So you pay the same price as base model inferencing in order to test out that fine-tuned model. If you've used some of our competitors' platforms, this is substantially cheaper. Our goal is fine-tuning shouldn't be scary. You should be able to come in and say, I want to test if I need to fine-tune. Shouldn't cost $1,000, shouldn't cost $100. You should be able to kick the tires, experiment easily and at low cost. So developer tier lets you deploy that fine-tuned model, no hosting fee, same price as base models for inferencing. You can evaluate it and you can answer the eternal question of, have I made it better or worse? And if you, like me, have made it worse, you can keep experimenting at a very low cost until you get it right. And then once you get it right, we're enterprise ready. We're going to talk about GAing new PTUM, global deployments, as well as extended model lifecycle support. So if you think about our announcements, our focus is really, number one, making it easier than ever to get started. So all of the best models, all in one platform. You can use OpenAI models, you can use open source models. We have new models available to you. We have new techniques. Once you've done that, global training. You don't have to wonder where fine-tuning is. Just create your resource. You can train from anywhere. Then you've got developer tier to unblock experimentation, no hosting fee. Once you've gotten started, you've created your most amazing model. You've copied Omkar's demo. We're making it so there is a clear path to production. If you fine-tuned before and you had a model you liked, you might have said, oh no, why do I only get 250K TPM quota, and why does Alicia keep declining my quota increase requests? We are fixing that. You get higher quota limits. We have customers in production running 30 million TPM on fine-tuned models. Alongside that, we are GAing provision throughput for fine-tuned models, as well as global standard deployments. So these are really great packaging, great ways to inference. A lot of folks say, I don't want to use that. It's a preview. I want something I know is going to continue to exist, that I know has SLAs. Final announcement on this slide is we're extending the model lifespan. So some of you may have fine-tuned 4.0 or 4.0 Mini, and then gotten those emails that said, oh, this model is going to be deprecated in a month. And you probably were like, I'm not going to curse on stage. You were like, oh no, I am very sad. What will I do? Might have sent me some hate mail. What we're doing now is you can keep using that fine-tuned model. You have a dependency on that model. You get to use that model for 1 year post-base model deprecation. So you've got your fine-tuned model in production. You can keep using it while you generate your training data to fine-tune a newer model. We're not going to force this migration in a matter of days. So you have confidence once you've created your model, you can keep using it. Now we're going to get a little more technical. Those were all like cool enterprise-ready stuff. One of the things that the data scientist in me is most excited about is we're offering reinforcement fine-tuning. So typically we talk about supervised fine-tuning. I teach the model to copy. Really good at changing style and tone. Not really good at domain adaptation. Reinforcement fine-tuning is for those reasoning models, and it teaches them to reason in new ways and about new domains. And the way it works is supervised fine-tuning, you have prompt and response, model learns to copy. Reinforcement fine-tuning, you have prompt and reference answer, and you define a grader, and you score how well the model's response matches your reference answer. Good idea to give partial credit. And then you reward the model when it gets closer to your answer, and you penalize it when it's further from your answer. And that reinforcement learning feedback loop is used to adjust the chain of thought in that O4 mini model so it can reason about a new domain. This is exciting because it's really good for complex use cases where you have things that are like verifiably correct, like you can look at it and be like, that's right. But the logic that goes into getting to that is very complex. You can't write it down. You can't say A, B, C, D, done. This might be something like legal use cases where not all of us are lawyers. It might be something like biological domain knowledge or math. So I'm going to hand it back to Omkar to show you what this means in practice.
Thank you, Alicia. So in this demo, what we're going to do is we're going to take an O4 mini model and improve its reasoning capabilities using reinforcement fine-tuning in Azure OpenAI. So most of the times we think of LLMs as text completion, auto-completion. But we don't want to do that. We want to improve the reasoning capabilities of this model. So that's what we'll be doing in this demo. So the structure is the same as the previous demo. We're going to look at the data set, talk about what the objective is. We're going to do base model evaluation first. Then we're going to have RFT run completed, and then look at how it stacks with the base model runs. So let's talk about the data set. So for this one, I'm choosing a data set that comes from a game show, a super interesting game show where you get a target number and 4 numbers. And you have to create an expression, an arithmetic expression that results in a value which is closest to the target number. Now, this one is pretty good for an RFT kind of demo because, one, it doesn't have a exact answer because you could have multiple expressions coming to the same target. You could evaluate the result pretty easily because you just have to run the expression and see whether you get the right value or not. But generating the expression is pretty hard. It's an NP problem. You can't really do it in quickly. So with that, let's just go ahead and have that data loaded up and see what the thing looks like. So as you can see, you have the target number and an array of numbers, and that's it. You don't have any labels. You don't have any ground truth expressions that you can use.
And you don't provide any example of like the expected chain of thought to get there.
No, you're not providing any expected chain of thought either. So the model is going to reason by itself and figure out how to do a better job of it. So before we start, we need to set up the 3 core things that you need for RFT. One, you need to have a good system prompt. Here we are telling the model what it's supposed to be doing. Then we have a good response schema which restricts the output of the model to a thing that you can actually use in your model grader. And the grader itself to grade the responses in a range of values to show that, hey, whether the model is coming closer to the expected answer or not. So let's go ahead and look at the system prompt. The system prompt is basically the rules that I mentioned about the game show. It also talks about a few examples to kind of show how it's supposed to be done. This is not like the chain of thought, but it is just the output and the input, but the format. Once that's done, we're going to use the system prompt at 2 places when we are calling the model for inferencing, as well as in our training data itself, so that the training samples have the instructions as well. Next up, the response schema. Here we are just ensuring that the response of the model is a structured JSON. That way we can parse it during our grader session.
And do I have to have a structured output for this?
It's better because that way you can write your grader in a more structured way. Otherwise, you'll have to have difficulty in terms of how things are going. So in our case, I'm going to have it as 2 values, result and expression. That's it, and I don't need any explanation or anything else. And then finally, the grader itself. If you remember from the previous demo, we had used an auto grader, but we also had ability to do custom graders. So we're going to use a custom model grader here. And the grader is written in a way that it gives a score between 0 and 5. 5 being when you get the exact answer, it has used exact number of numbers that it's supposed to use, the expression is valid and everything. And then it degrades as in how the numbers go. So here's my grader. Now with all of that set up, I'm ready to start evaluating the base model. So we're going to use O3, O4 mini as the two reasoning models, and we're going to use 4.1 and 4.1 mini as our non-reasoning models for this evaluation. In the interest of time, I've ran that before, and let me just open up the eval run, and we'll make sure that I'm opening up the one that I'm supposed to. Oh, here we go. As you see, there is a huge difference between the reasoning and non-reasoning model in this particular task. Both O3 and O4 do reasonably well, and 4.1 and 4.1 mini are not so good. And that's understandable because these problems require deep reasoning and not just completion of the text. So the rest of the demo, we'll try to improve the performance of O4 mini to see how far we can reach by using reinforcement fine-tuning. Okay, so with that, let's just go ahead and start the fine-tuning run. All right, so now we have introduced a customization method called reinforcement. This is in addition to what we already had with supervised fine-tuning and DPO. We support that on O4 mini, so let's take that. Let me make sure that this breaks up properly.
And when something goes wrong, that's how you know we're not just going from a recording. What region
Wait,
is your
that's
source
okay.
in? There we go.
Let me make sure that this is, yeah, there you go. All right, so once that's done, you can go ahead and select your training data. I have already uploaded. And now here's the thing, for reinforcement fine-tuning, you don't need a whole lot of data. You can start with as little as 15 or 25 samples also. I start with 100 because I've seen this to be working fine there. And you always need a validation data for reinforcement training. That's where the model graders will run and ensure that you're going the right direction. So we take about 50 samples for validation.
And just for comparison, so you said, oh, I only need 25 to 100 samples. How many were you using in the distillation demo?
In the distillation demo, I was using 1,000 samples. That's kind of even small for supervised fine-tuning. You can go a lot bigger. And here I would recommend to start smaller because reinforcement fine-tuning can take longer as well. You want to make sure that your setup is all ready, your graders are working fine before you go ahead and commit to a much larger run. All right, after that, you have a hyperparameter to determine how much reasoning effort the model should put in during the sample generation. So I'll keep it at medium. You can either increase or decrease it as you permit. So now let's put on the grader schema and the response schema that we had defined in our notebook before. I'll pull that up.
And while Omkar is copying that, you might be like, well, this looks like some pretty complex JSON syntax. We also have, you'll see that little sparkle where it says generate, where you can type in, I need a grader that grades for 2 fields, numerical response and explanation, and it should be exact match. So we try to make it a little easier for you if you're not as good as Omkar is at memorizing complex nested JSON.
Absolutely. All right. So now that we have the response format and the grader added up, you can go over a bunch of other hyperparameters. Some of them are familiar, some of them are new, specifically the evaluation interval and the number of samples that you want to use on evaluation. I'll keep all of them as default for now, and let's submit the run.
And so I know we're going to cooking show demo this one too, but if we were to just sit here, how long would this take?
The one that I ran, I think it took at least an hour and a half to 2 hours for around 100 samples.
Okay, not bad.
Yeah, but it takes some
It would be
iteration,
boring,
but it will be.
But
Okay. So in addition to that, one thing that we have also introduced, I think, which we did not announce in our slide, was the ability to pause and resume the runs. So with RFT, we have the ability to actually go ahead and pause an ongoing run. At that point, we create a checkpoint, and you can use this checkpoint to deploy, figure out how the evaluations are working for you, and then decide whether you want to continue furthermore in more epochs and things like that, or you want to just stop at that point. So that's done. Once that's done, you go ahead and deploy it. I'm going to open up an evaluation run that has both hold on, let me, oh yeah, it has both the base models and the fine-tuned models, and see how they stack up. There you go. So as you can see, we see uplift of around 12-13% on the O4 mini model. And remember, we got the uplift just by using 100 samples, no data, no label data, and just the reward signal itself.
and default values.
And default values. And with that, let me just quickly glance over the notebook so that I don't miss out anything that I was supposed to say. Here, this notebook will be available for you. You guys can go ahead and look through the entire details in the evaluation. You can see which were the expressions that were improved by the fine-tuning and things like that. And with that, we are at the end. And back to you, Alicia.
Amazing. So let's toggle the screen
Oh, yeah.
back. We'll have a link at
We'll
the
have
end,
the
so
link
you
up
can
there.
get all of this code and hopefully run it, deploy it on developer tier. So the last thing I like to talk about on RFT is I'm a product manager. Any of you guys know you can fake a demo. We could do a very convincing fake demo, but customer evidence always drives it home. When you see these new kind of like mode-changing features, RFT is a big deal. I always like to pair that with someone who has actually tried it out. And so in our private preview of reinforcement fine-tuning, we were working with DraftWise. They're a startup in the legal domain, and they were using RFT to teach O3 and O4 Mini how to reason about contracts in order to review them and help lawyers process data faster. And this is a good use case because they were able to say, you know, this is a valid contract, this is an invalid contract, but there's a reason lawyers get paid so much. There's a lot of domain knowledge and a lot of reasoning that goes into that. So that's a really nice use case. I also like to point out that fine-tuning, yes, we offer that to all of you all, and we're super excited about that. And I'm gonna bet we also have some Microsoft people in this room. Fine-tuning is our secret sauce for our products as well. So one of my favorite use cases is Dragon Copilot from Nuance. They use a fine-tuned model in their EHRs. They do basically transcription from doctor-patient visits, and they use a fine-tuned model to summarize those interactions. Using these techniques, they were able to go from base model to their final version of a fine-tuned model, get 50% increase in accuracy. And you're like, wow, 50% is a big number, but also think about healthcare domain. 50% means the difference in quality of care, patient outcomes, patient satisfaction. So fine-tuning really is a level set for this company. We also have GitHub Copilot. This is probably not surprising to you all, but these are fine-tuned models. These code completion models are fine-tuned for these languages. And through the process of fine-tuning and reinforcement learning, they're able to gain over 30% increase in performance. These are great slides, but it always also helps to talk to someone who's actually using this. So Shri, come up on stage and show us what you guys have built.
Yeah, hopefully you can hear me. Yeah, I'm Shri, and I lead clinical AI at Oracle Health. And over the past year or so, my team has been building and shipping agentic solutions to doctors and nurses to use at the point of care, which is hospitals. So we're pretty proud of it. And I guess the Azure OpenAI team has been a great support from getting us into the previews of various models, all those nice quotas, just keep them coming. So today I'm going to share one of our fine-tuning journeys. And hopefully you can pick up like what model choices and trade-offs that we have to do. And a lot of developers actually ask me, hey, where do you need fine-tuning? Isn't it too costly? You know, both time-wise and actual cost, right? Dollar cost and so on. So yeah, hopefully you can get some insights. I guess first, I have a bunch of like mandatory input tokens for all of you to process, disclaimers and such, but it's okay. No need to produce any output tokens. All right, so at Oracle Health, our goal, one of the key goals at least, is to ensure clinicians actually do what they love doing the most, which is caring for patients. And we want the agents to take over some of the administrative burden. When I say burden, think of documentation. We know doctors have to spend like an hour to hour and a half every day just writing notes and looking for information as they prep for their next patient. Sometimes they have to find information in multiple places and stitch that by themselves, right, in their brain, essentially, to get to the answer they're looking for. And there's a ton of data entry as well, right? Like for discrete things, like when someone comes in and asks you, hey, how is your pain score now? They have to take it and enter it into the electronic health record, right? So that's a lot of work, and we want to have the agent significantly automate these things, but then by always keeping the healthcare provider in control of things using a human-in-the-loop architecture, because we don't want to create any patient safety risks, right? So the solution to our vision is called the clinical AI agent, right? It's a multi-agent architecture that's deeply aware of the provider context, like what do they do, what is their specialty, what is the usual demographic of patients they see, and also deeply understand the patient. What is going on with the patient, problems, and like what meds they're on, all that stuff, to proactively drive the clinician workflows so that they're efficient, right? So it can cut down the time that they spend on all these administrative tasks by 1 to 2 hours a day, which is a lot of time, right? So without taking any more time speaking, I'm going to get to a real demo. I'll first log in. I guess for this part, I'll have to wear my fake doctor's hat.
White lab coat.
Oh, wow.
That's okay.
All right. Since I'm a doctor, I'm trying to figure out how to, I guess,
Do you need IT
charge my
support?
computer. I didn't realize it ran out of charge, or I guess that power is not active.
Uh-oh.
All right.
It is not on the screen yet.
No, it's still working. And this is the time where we tap dance.
All right. Let me try logging in.
All right. Okay.
Again, this is not a recording. We're doing this live.
Yep.
If it was a recording, it would be going more smoothly. And as you're logging in, is this something that's actually in use today?
Soon. So some agents are in production. Some are going to be there very soon. So here, like I said, I put my fake doctor hat on. I'm Shri. I'm an outpatient physician. I see about 15 patients a day because they go in like 30-minute appointments, right? And I have usually barely 3 to 4 minutes between my encounters to kind of prep up for my next patient. So here, the clinical AI agent understands my schedule. It knows who I'm seeing next. It's Sam, who has been my patient for the past year or so. And since it understands the reason for her visit, which is a follow-up for sinusitis, it is able to use its knowledge graph to pull out what are the conditions, other conditions, meds, labs, imaging, those that are relevant to sinusitis, and like pull all of that information into one generative AI produced summary. It's kind of like taking all those needles in the haystack and putting it at a single place, and that's the first thing I see, so that like I quickly get up to speed in those 2 minutes that I have to prepare to see her. So let's see what it says. So it's a follow-up for sinusitis. I've last seen her on the 13th, and it talks about like the relevant imaging, that is the CT sinus. So I guess that looks good. So now I'm about 80% there. So I want to ask a few questions to kind of get to all the understanding before I go into the room. So let's try. Show me her latest labs. All right, it's a live voice demo. Let's see. Cool.
Woohoo, it worked.
So it's great that I don't have to go anywhere digging into all the tabs. Traditional electronic health records are like, there's 100 tabs, right? You have to go here and there every time you need something. I don't have to go anywhere. I get all the results right here. Just the abnormals. So conversationally, I can just ask for a filtering of those labs, and it gets me kind of just the abnormals. So looking at these, I guess there are some outliers, but it's okay for what Sam is going through right now. So let me dig in a little more into sinusitis, I guess. How many episodes of bacterial sinusitis has she had the past year? So for this, the agent has to go look into all the discrete and unstructured information in the EHR, both in the health system like my hospital and also all the other hospitals, right? Like these information silos are like really common. Interoperability continues to be an issue in healthcare. So the agent came back. She has had 2 episodes. I can dig in if I want to. So this one, what's going to come up is a more condition-oriented summary. The summary we have seen before is like a pre-visit summary. It's a little more high level. This one digs into bacterial sinusitis a lot more. The onset, what meds have been prescribed, anything else, right? Like that's just like more dense and into that sinusitis thing. What symptoms has she had? So again, conversationally, I don't need to repeat myself that I'm still talking about bacterial sinusitis. It'll hopefully come back to me with like the specific symptoms, so that like I'm 100% prepared and before I go meet Sam. All right, so that's that. So if I go back, hopefully.
Amazing demo. What did this have to do with fine tuning?
Yes, so that's what I'm going to go, right? So while that experience is powered by a bunch of models, of course, speech models and small to large, like there is a spectrum of language models that are behind that thing. The specific model that I'm going to dive deeper into so that I can answer that question of where fine tuning and why fine tuning, I call it the orchestrator. Its job is actually quite simple at face value, which is like take that input, like show me her labs, and actually decide where to route it, right? Sometimes based on all the app context, like what people are seeing on the screen, the conversation history, and the patient context, it has to route to a UI plugin, right? Like what we have seen. But some other times, it has to delegate that request to a search agent that's going to look into notes or other discrete data. So I guess for people familiar with tool calling, we kind of made it a tool calling problem, right? All the UI, APIs, and other agents register themselves as tools, and this particular model, the orchestrator, picks the right tool and extracts the arguments for it, right? So now, let's get to why fine tuning. Healthcare, of course, takes accuracy very seriously, right? We understand that, but interestingly, this use case cares a lot about low latency. Agent responses, for example, especially the ones where the UI refreshes, right? It has to happen under 800 milliseconds. That's the latency constraint. If that doesn't happen, obviously the users are going to go back to disengage and go back to the UI clicks, which is not the behavior we want. And 4.0 doesn't cut it, right? It takes like a minute, a second, or like 1100 milliseconds. So those 200 to 300 milliseconds that we can save with 4.0 Mini is actually super important for us. However, we know that the 4.0 Mini doesn't satisfy all the accuracy targets for us, but with as small as like 1500 high quality supervised fine tuning data set, we were able to kind of fine tune 4.0 Mini to get to the accuracy targets we need. So interestingly, it happens to be latency that pushed us towards 4.0 Mini, which needed fine tuning. Now, I just want to take a couple of examples to show what are we trying to teach it really. It so happens it's all about like how to interpret the rich context to do the tool picking and argument extraction. In this case, show me low priority messages, right? It has to pick the messaging UI and extract priority is low. But a follow-up question, which is unreads, it has to retain that tool, pick the priority is low from the conversation history, but then status is unread from the input. So it's trying to pick and choose like, hey, I'll take this from the input, this from the conversation history. Together, I'm going to come up with arguments. Another quick example, this is about renewing meds. It's renewing, so which means the patient is already on that med. So here, the model has to extract, well, first understand it's the ordering agent and the renew action. That's actually pretty straightforward. But the detail comes into like, hey, I need to extract the drug name from the input, and then I need to go into the specific JSON in the patient order profile to find the dosage, 10 mg, and the route it's called. It's the tablet versus injection versus some other form. And then if it's allowed, that's another key in that JSON. Then it needs to let the renew happen. If that's false, everything else the same, it cannot pick that action. So this is the kind of like complexity of like trying to pick through the rich context and kind of make that decision on the tool choice and action. We started this even before 4.0. So as you can imagine, with 3.5, where the context window is 16K, and our base prompt length without any ICLs in context learning examples is 15K. We had to go with fine tuning as the only option. But even when we got 4.0, which has 128K context window, it turns out the context is ballooning. Like as you take those bite-sized instructions from fine tuning and put it as ICLs in the prompt, given the size of the JSONs, right, it actually grows pretty rapidly. which again impacts like latency, time to first token, but also if you went deeper into tool calling, unlike the generative summaries and so on, you can't really do system 2 thinking where you can force the model to output like step-by-step reasoning before it picks the tool. It's an actual technical limitation of tool calling models. So it doesn't work as well. So because it eventually ends up as a rule-based system, it has to pick and choose which one to apply and combine them and so on. So short of it is our evals made it pretty clear that the fine-tuned model candidate is far superior than the prompt engineered model. So hopefully that gave a sense of like our model choices, why we had to go with fine-tuning and so on. And of course, I guess specifically I want to talk about LoRa. We did not want full fine-tuning because of course, like we don't want our fine-tuning to actually erase any learnings that come from post-training. Who knows? OpenAI must have done, actually, while we don't know what they've done, they must have done some training to teach the model tool calling. It's pretty popular. We don't want to lose that. Of course, we want quick iteration. And of course, all of those features are on checkpoints, evals at every checkpoint, and starting with a checkpoint and getting to another checkpoint, all of that is good. And of course, we're going to keep bugging Alicia and the team on more and more customizations. So yeah, so that's it. I guess hopefully you learned something about the model choices and trade-offs around latency, accuracy, and dev efficiency that goes into your base model choice and prompting versus fine-tuning. I'm super excited about like 4.1 and like revisiting the same trade-offs and model choices with like 4.1, mini, and nano, right? There were some things that were said about in the talk yesterday, but like 4.1 mini being as good as 4.0 when it comes to accuracy. And so maybe 4.1 nano can get to the same accuracy as 4.0 with some fine-tuning. We'll have to see. All right, thanks for listening.
And I'm going to ask you one question, because we're on stage together, so I can take that privilege.
Sure.
And I haven't asked you this before, and I hope I don't regret the answer.
Sure.
But what is your time from like, I'm ready to fine-tune a new model, to getting that model up and running?
Yeah, good question. So the bulk of the time goes into the dataset prep. Less is more, as most of the papers suggest, right?
Yep.
And so, once you have the dataset, it's super quick. But it takes a bunch of experiments to even figure out like what is the data. So maybe 2 weeks goes into at least, like, again, if you're grounded in your use cases and you get help from customers to understand exactly what's happening and what's needed. Maybe 2 weeks to 3 weeks to get to the data, and then if you did it right, then usually it's super fast to get to the model fine-tuning iterations.
Nice.
And then the evals is the thing that's going to take a lot more time. I mean, the training time is only like 20%. The data and eval is usually the 80%. Right?
I think that is like a big take-home message, is people can be intimidated, fine-tuning, oh no, training, do I need a PhD? You don't. Training is honestly the easiest part. You've seen us do it. Click, 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 defaults, go, it's done. It's data, it's evaluation, it's scaling up. That's a lot of work.
Right.
Thank you. You can hang out with us. We're going to take questions after that. So I'm going to end with like, why Azure fine-tuning? So I've been hanging out in the expert booth, and people have come by and said, why Foundry? Why not use OpenAI? Why not do it myself locally? And one model choice. We've really focused today on the OpenAI models, but we actually have many open source models. So you can choose OpenAI, Llama, Mistral, Phi from Microsoft, NCT models. We also have a much wider selection from Hugging Face. And you can choose the kind of mechanism you want. We offer serverless fine-tuning, which is what all our demos were today. Cheap, easy, fast. You don't have to worry about the infrastructure. Or if you have quota and you want to do something very complex, use managed compute. Do it your way. Reliability is a big one. We've seen customers actually migrating from other platforms to Azure, looking for that 99.9% availability SLA. We've seen customers say, we love our fine-tuned model. It's great. It can't go down. We just talked about GAing P2UM. You get latency guarantees. So we have a platform built for enterprises, built for scale, and built for production. But the Foundry platform is a platform. You've got everything you need in one place. You don't have to go find this library here, that library there, go get this third-party tool over here. You've got models, training, evaluation, deployment, metrics, all of that in one simple-to-use UI. And finally, scalability, both small scale and big scale. So we make it really easy to start small with low-cost developer tier hosting, global training, so you can kick the tires and say, is fine-tuning right for me? Were Alicia and Omkar lying? I'm gonna find out. And then once you have your model that you like, you can scale up with P2M for production workloads. And with that, I know some of you were like, can we see the code? Here are CTAs. Get started today, ai.azure.com. Try the demos, aka.ms, ft-build demo. All the code is there. You can run these yourselves. And find out more by checking out our docs. And we were fast. We did it on time. So we've got about 5 minutes for questions. Folks can come up to the mic so we can hear you. And I'm excited to hear what you have to ask.
Thank you.
Thank you.
Yeah.
Hi. One question, because I completely understood, I believe, those two use cases, but I don't really get how to use a fine-tuning to improve the accuracy of a tool calling.
So Shri, do you want to take that one since you've done this in practice?
Can you repeat?
So he was asking, he understood the two use cases in our demo, but how does fine-tuning help improve accuracy with tool calling?
Yeah, so I guess like picking arguments from context and like the subtleties there, right? Usually what we find is like these instructions are always not like super obvious. Even for us, right? We'll have to take these constraints into consideration, but what you end up doing with a complex JSON really might require the model to do a little bit of interpretation of multiple rules and apply what makes sense, right? And that is the part we believe that it's picking up using the LoRa kind of fine-tuning. So yeah, I guess it depends on, maybe the complexity, like conversation. In our case, it's conversation history, how nested the arguments are, and such things. But in your use case, it might be different set of things. So basically, it's I guess how much reasoning like stuff it's kind of trying to do. It's not true reasoning like in O3 and others, but yeah, it's a little bit of like trying to understand multiple instructions and fuse them to get to whatever tool choice and extraction. I think especially extraction, like if you have a lot of parameters to extract, that's when it might help more.
And I think simplifying that, like if you think of fine-tuning, the easiest way to understand what fine-tuning does is it's show, don't tell. You show the model how you want it to behave instead of saying, here are all the APIs you can call and this is when you should call them. So to improve tool calling accuracy, you provide lots of examples of situations, here's the prompt and here's the correct tool call. And you would also provide examples of prompts where you don't call a tool, so that you teach the model what tool to use in what context and improve accuracy.
So in other words, it's still reinforced, but also taking into account what tools has been called?
Yeah, you have to show it what tools exist. So these are the APIs I have available to me, and you show the model, this is when you call this tool, this is what you do with the responses. Another question?
Thank you.
Thank you.
So I'm curious more about the costs. So fine-tuning costs, now you said it's going down, but from fine-tuning to production, hosting it on production, how much is the cost?
So,
estimated ballpark.
So it's all going to depend on your tokens. You can choose either pay-as-you-go pricing, where you're going to pay an hourly hosting fee for your model. It's $1.70 an hour. And then you're going to pay the same per token rate as the base model for inferencing. Otherwise, you can use provisioned throughput, where you purchase PTUs. Those are fungible between fine-tuned models and regular models, OSS and OpenAI models now. And that gets you a certain amount of throughput, and you're no longer like paying per token. You're just paying for those PTUs.
So I still can go on pay-as-you-go?
Of course.
Okay.
And I will say we have folks on pay-as-you-go running those, I think, 10, 20 million TPM workloads.
And for your example, the training, I saw 3.9 million tokens were used or something like that?
That's the entire training token cost.
Yeah, okay.
And for tokens, for training for the chat models, like 4.1 mini, you pay per token. And so there's usually a price for a million tokens, number of tokens times number of epochs equals training job cost. I'd say a lot of jobs come in under 10 bucks. Yeah. What Omkar showed you is probably under $1. RFT is more expensive. That's charged by the hour. And that's just because it's much more computationally expensive.
Okay, thank you.
Thank you.
Thanks for the presentation. If I'm just starting out with this and I need to build my team, do I need like an army of data scientists to do this fine tuning and like a whole bunch of AI ML engineers? What do I need to get started with this?
So just to repeat your question, you said, do I need to hire an army of data scientists? And this hurts me deeply as a former data scientist, but no. This tooling is basically, you don't need to hire me. You can do it yourself. If you are a SME, a subject matter expert who can define your use case, collect the data, we deal with all that training for you. No more setting up MLOps pipelines. We make it super easy. So you just need to know the problem, curate the data, and press train. And with that, we're out of time. Thank you all so much for joining us. Please stop by the expert booth if you have questions.
Thank you.